Hello everyone, I'm here with one of the important theorems called Pythagoras theorems. What does this Pythagorean theorem states? Okay, here we have got Pythagoras theorems states that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. Okay, so here we have got the theorem, right? Now, without any delay, let me start the session. Okay, so here we have got, okay, here we have got the diagram, right? If you see the diagram, here is the diagram, right? So in these diagrams, what we have got, if you see, this part is hypotenuse, right? This part is hypotenuse, this part is base, right? Leg no need to mention here. This part is, this side is base. Okay, now here we have got, this is, here what we got, height. Okay, this height is also called as perpendicular. What do you call it as? Perpendicular, right? This height, this side, perpendicular. What do you call it as? Perpendicular, right? This part is also called as perpendicular. Okay, this one, right? We are talking about this side. Okay, this is also called as perpendicular. So here we have got base, okay, and here we have got, this is base, this is perpendicular, and this is hypotenuse, right? Now as per the theorems, what we need to prove, okay, let me go to the next screen. What we need to prove, okay. So here we have got, let me take a diagram. Okay, let me take a diagram, right? Say that this is one right angle triangle. Okay, this one right angle triangle. Say that this is base, right? This is base, right? This is perpendicular, and this is hypotenuse, right? This is perpendicular, this is, here we have got base, right? Here we have got base, hypotenuse, and perpendicular, right? I mean, this one is base, this one is perpendicular, and this one is height, right? Now as per the theorem, what is told, that is square of the hypotenuse. Okay, let me draw here one square. Okay, let me draw here one square. Let me draw here this square. Okay, here we have got a square, right? Say that it's a square, right? Now a square will be here also. Okay, and say that here we got a square, right? And as we know, as we all know that, okay, that is that is the side of the squares are equal, means we can say that this equals to this, right? Equals to this, equals to this, right? Another, this, okay, equals to this, right? And this equals to this. It means here we got in the square. Okay, now if you see in this one, this side equals to this side, this side, and this side. Okay, these sides will be equal, right? These sides will be equal. So here we got, okay. Now suppose if we talk about the area of a square, okay, what I am saying, I'm saying that area of a square. Okay, if we talk about the area of a square, right? Area of a square, area of square, right? Area of square. Okay, area of square, what is the formula? The formula is side square. Okay, the formula is side square, the formula is side square, right? This is the formula. Okay, that is area of square equals to side square, right? So if I talk here, here we have got h, isn't it? Here we have got h, means if I talk about the area of this part, okay, this region, area of this region, okay, if I talk, so I'll write here h square. Okay, area of square will be h square, right? If I talk about area of this region, right, so its area will be how much? Its area will be p square. Is this clear? Because area of square is side square. Okay, its area will be p square, right? Its area will be what? P square. Now excuse me. Now here if you talk about the area of this part, okay, area of this region, right? So here if you have, okay, here what you have got, b, right? So here what we have got, here we have got b. Okay, so here it will be b square, right? Area of square is side square, so as I've written here is b square. Okay, so it's done here. Now see, in case of the Pythagoras theorem, okay, in case of the Pythagoras theorems, we talk about these things only. That is what we talk about. Okay, we talk about, that is h square, right? H square is equals to, okay, base square plus perpendicular square. Okay, this is called Pythagoras theorems, right? Now we need to prove it. Okay, now we need to prove that how it comes. right? So in the part of the solution, right, in the part of the solutions, right, let me take one right angle triangle. Okay, so let's start the solution. Okay, let's start the solution. So in the part of the solution, let's take one triangle, right? Let's take one triangle. Okay, let's take one triangle. So here say that this is A, right, this is B, right, and this is C. Just say that. Okay, A, B, and here we have got C, right? Say that it is right angle. Okay, angle A is right angle. Now what I have done, from here let me draw one perpendicular. Okay, from here let me draw one perpendicular like this, right? So here I've got perpendicular. Say that this is perpendicular. Okay, so let's name it D. Let's name it D. So here we have the diagram. Okay, so from this diagram, if what I have to prove, I have to prove this thing. Okay, I have to prove these things, that is h square equals to b square plus p square. Is this clear, right? So here if I talk about the hypotenuse, okay, if I talk about the hypotenuse in this question, okay, for these questions it means I can say that in given part, okay, in given, if I talk about, okay, what I can say here, what is given here, here you have got BC, okay, that is H hypotenuse equals to BC, right? Hypotenuse equals to BC, and then say and then say what I have to prove. Okay, what I have to prove here is, I have to prove here, that is BC square, right? What I have to prove here, let me take to the next page. I have to prove, okay, here to prove, right, to prove. If I talk about to prove, okay, so to prove it's, okay, I have to prove here. So what I'll be proving here, BC square equals to, right, BC square equals to AB square, okay, AB square plus, right, AB square plus AC square. Okay, from this diagram I have taken here. Okay, from this diagram I'm talking about, right, I have taken here, this is this BC, right, this BC and this AB, right, and here you got this AC, right? Now now here see what I have to do here, right, to prove. Okay, then what I need to do, okay, I need to do construction, right? So what I'll be doing here, I'll be doing here constructions, right? So in the part of construction, what do you write here, in the part of construction, right, in the part of construction, what we'll do here okay, in the part of the construction, right, what we need to do, we need to, what we need to do, okay, we need to draw a perpendicular. Okay, so what I write here, draw, right, what I have done here. Okay, if you see here, this perpendicular has been drawn here. Okay, that is AD, perpendicular to BC. Okay, draw AD, right, it's AD, perpendicular to BC. Okay, perpendicular to BC. Is this clear? Perpendicular to BC, right? Now now in the part of proof, okay, in the part of proof, okay, let me take in the part of the proof. Okay, in the part of the proof, let me take this, right? So in the part of the proof, okay, if we talk about the diagram, we have in this way, right, that our diagram is in this way. We have this our diagram. Okay, this is our diagram, right? Here we have got A, okay, here we have got B, here we have got C, and here we have got D, right? Here we have got D, right? Now in the part of the proof, okay, if I'll go for the part of the proof, and if we'll try to solve this one, okay, let's see what we'll find here. So what we'll do here, okay, in the part of the proof, we'll say that triangle, right, triangle ABC, okay, the bigger triangle ABC, right, is similar to triangle, okay, the triangle ABD, okay, triangle ABD, right, triangle ABD, right, is similar to triangle, okay, the third triangle we have here, that is ADC. Okay, ADC, right? Which are the two triangles I have taken? Three triangles I have taken here. If you see here, the two triangles I have taken. So here I have taken three triangles, okay, similar triangle ABC, okay, triangle ABC, right? Here this triangle I have taken. Which is triangle ABC here? A, this is A, B, C, right? A, B, C. Another triangle I have taken here, that is ABD, okay? So here A, B, D, like this, right? Another we have taken here, another I have taken here. Which one is that? This is ADC, okay? So here you have got ADC, right? ADC. These triangles I have taken, okay? Now see, in the part of the solution as we have written here. Now let's go to the next page, okay? So in the next page, if you see, okay, let me draw that triangle here, right? Let me draw that triangle here, the same triangle, that is A, okay? Here we have got B, here we have D, and here we have C, okay? This is our diagram, right? Now see, in the part of the solution, okay, since what we know that since, okay, since, right, since triangle ABD, since triangle ABD, right, triangle ABD is similar to triangle ABC, okay, is similar to triangle ABC, is similar to triangle ABC, right? Now since they are similar, okay, so what we can write here, okay, means what we can write here, as we know that the in the similar triangles, okay, the sides are proportional, okay, in the sides are proportional. So here what I can write here, I can write here, okay, here what I can write here, I can write AB, right, A B by what I can write here, BC, right? AB by BC is equals to, right, what I can write here, BD by AB, okay, BD by AB. How it comes, okay, how it comes, see, as we know that in the similar triangle, okay, if the two triangles are similar, their corresponding sides are proportional, okay? What we know about, okay, what we know that, okay, that is, now so here we have got the rules of similarities, okay? If right, if two triangles, right, if two triangles, if two triangles, if two triangles are similar, right, are similar, if two triangles are similar, right, if two triangles are similar, then what are the rules we have, okay? Which are the rules we have, okay, if we talk about the similarity, okay? Number one, corresponding, right, let me write here corresponding, it's corresponding, right, corresponding, 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 right, corresponding. Number one, if we take, okay, corresponding sides are proportional, right, corresponding sides, corresponding sides are proportional, are proportional, are proportional, okay, corresponding sides are proportional, right? Number second point, number second point, corresponding angles, right, corresponding angles, corresponding angles are equal, okay, the corresponding angles are equal, corresponding angles are equal, okay? So these are the rules of what we say, the similarities of triangle, okay? Let's back to the first part, okay? So here what we have written here, if you see here, I have taken from triangle ABD, here you have triangle ABD, okay? From here what I have taken here, I have taken this side AB, okay, this side AB I have taken. So this side AB is hypotenuse for this triangle, right? Another, for the bigger triangle I have taken here BC, So this BC is the hypotenuse for this bigger triangle, right? So here bigger equals to, then I have taken BD. So from this smaller triangle I have taken this BD, right? This BD part I have taken. Another thing I have taken an AB. So from bigger triangle I have taken this AB part, right? Now this one what you can write here, okay? This one what you can write here, if we'll do cross multiply AB into AB, okay? So we'll get here AB square, right? AB square equals to, right? AB square equals to, then if you see here BC, right, into what you have got BD, right? BC into BD, right? BC into BD. So say that this is equation 1, okay? This is equation 1, right? This is equation 1. Here we have equation 1, okay? Now let's move to the second part, okay? In the second part what we can do, let's have the diagram here. This is our diagram, right? This is our diagram. Here we have got A, okay? Here we have got B, here we have got C, and here we have got D, right? This is our diagram, okay? The same diagram I have drawn here. Now in the second part if you'll do, okay, so our second part, here we have got second part, that is triangle ACD, okay? Triangle ACD, triangle ACD is similar to triangle, okay, ABC, okay, ABC, right? ABC, right? Now I'm taking this part, this triangle, right, and this bigger one, right? Now what you can write here, therefore what you can write here, therefore, okay, therefore what can be written here, we can write here AC by BC, okay? So this side, okay, AC by BC, okay? AC by BC is equals to what you can write here, DC, okay? This one DC, that is CD, okay, by what you can write here, AC. We can write here AC. So if you see here, okay, if you see here what I have done here, from this triangle, okay, from triangle ACD, okay, triangle ACD, what I have taken AC, okay? So this AC is what, this AC is hypotenuse for this triangle, okay? It's the hypotenuse for this triangle, right? Now another things I have taken here BC. So this BC is hypotenuse for this bigger triangle, right? This is hypotenuse for bigger triangle, right? Is this clear? Then see another I have taken here CD, okay? What I have taken here, CD. So this base part of this smaller triangle I have taken, right? Another things by AC I have taken, okay? So if you see this AC, okay, this AC is for bigger triangle I have taken here, okay? Now if this one will do cross multiply, okay, what will get here, AC square is equals to BC, right? BC into, okay, BC into CD, okay? What will get here, BC into CD. Is this clear? So let's take that this is equation 2, okay? This is equation 2, right? We got equation 1 and equation 2, right? Now let's move let's go for the solution, okay? Now if you see, okay, what I'll do here, we'll add the equation, okay? So we'll write here adding, right? Adding, okay, adding equation, okay, adding equation 1 and 2, okay, adding equation 1 and 2. If you add equation 1 and 2, what we are going to get, okay? So as we know that, okay, in the LHS part, let's see, okay, in the LHS part of this this one, what we have got here, we have got here AB square, right? So I'll write here AB square, okay, AB square, right? AB square, it's AB square, okay? Let me change this one. We have got here AB square plus, okay, in equation 2, if you see in equation 2, in case of equation 2, what we have got, okay, we have got here AC square, okay? What we have got here, AC square, okay? So let me write this AC square here, okay? Here will be AC square is equals to, right, is equals to, now in equation 1, okay, in equation in RHS part, what I have got here, BC into BD, okay? So let me write here BC into BD, okay? BC into BD, okay? BC into BD, right? Since we are adding, so let me write here plus sign. Okay, now in equation 2, if you see, okay, what you have got here, BC into CD. What you have got here, BC into CD. Okay, so let me write here BC into CD. Okay, BC into CD. Is this clear? Now here what you can do, this one, AB square will be as it is. Okay, this AB square will be as it is, plus even this AC square will also be as it is. Okay, equals to, okay, equals to, if you see the RHS part here. Okay, here you have got BC, here you have got BC, right? It means what we can do, we can take BC as common, right? BC as common. So I have taken here. Now what I am left with, I am left with this BD here. Okay, so this BD I'll write here, this BD I'll write here, plus, and here what I'm left with here, CD. Okay, so this CD I'll write here. Okay, so here I got this one. Okay, so BC into BD plus CD. Now here let's do this one here, AB square, right? AB square plus what we have got here, AC square, right, is equals to BC. Okay, and this bracket means what, this bracket means multiply. Now BD plus CD. Okay, BD plus CD. Let's go to the diagram part. Okay, what you have got, this BD plus, okay, this CD. Okay, this BD plus CD, if we'll add this one, what we'll get here, we'll get here BC. Okay, what we'll get here, we'll get here BC, right? Here we'll get here BC. Is this clear? Is this clear, like how this BD comes? Okay, let me show you diagrammatically. Okay, we have the diagram like this. This is our diagram, right? This is our diagram. Here we have got A, here we have got B, here we have got C, and here we have got D, right? So what we are doing, we are adding this BD, okay, this BD, this part, okay, plus this part, right? This part plus this one, this means this BD plus this CD. Okay, we are adding this, right? So if we'll add this, we'll get this BC here, isn't it? So that same BC I have written here. If you see this one, same BC is written here, right? So this is how we got BC. Okay, now see in the in the in the diagram, if you see, okay, in the diagram if you see, okay, let me write here AB square, okay, AB square plus AC square, okay, is equals to, now this part what we have got here, here we have got, okay, if you see this one, what we have got here, we have got here BC into BC. Okay, BC into BC. So BC into BC, what will get here, we will get here BC square, right? What will get here, BC into BC, we will get here BC into BC, what will get here? Okay, here we have got AB square plus AC square is equals to BC square. Okay, this is what we wanted to prove in the question. Okay, so this we can say that proved, right? This we can say that it's proved. Okay, so this is all about the Pythagoras theorem. Okay, I hope I have been able to explain each and every points very properly and clearly. Thank you for watching.